Hello, my name is Jace Butcher. I'm going to be doing ADJ2 problem number 3 here. This is my YouTube video for the second assignment. I'm going to keep this one a little bit shorter, move quicker through the first few slides because they're pretty self-explanatory, get into the meat and potatoes with the analysis here. So the problem statement is, out of these 4 algorithms, which one should we use for the code that's given in the problem statement? I won't go through that whole code, I'm sure you got it there. We got the FIFO algorithm, the LRU, OPR, and the MFU. Some assumptions being made is that the choices available should all be evaluated, and we should only choose those 4, not anymore. Going through the requirements on slide 3 here, each option available should be equally considered. Like I said, no prior biases going in, just equally considering them for the code that we're given. There should also be a figure of metric used, and I will use a score of 1 to 10 for that. As we can see on this next slide here, number 4, I'm going to go through each 4 of these algorithms, compare and contrast their strengths and weaknesses in relation to the code snippet given, and then I'm going to give them a score of 1 to 10 based on how well they react to our snippet of code. Not grading the overall algorithms in general, but grading how well they perform at the snippet of code we're given. Jumping into the analysis here on slide number 5, the OPR algorithm is the optimal page replacement. This one is considered the most optimal, but the least practical. This one must know future requests in order to succeed or even to work. That's not possible with the snippet of code we're given. We don't know future requests, so I would give that one a 1 out of 10, just in regards to working with our code that we're given. It really won't, but that is obviously the benchmark algorithm what we'll use to compare the other algorithms with. It's just not very practical. Next, I'll go with the first in, first out algorithm. This is the FIFO. It utilizes a queue. So this queue orders the pages from the oldest in the front to the newest in the back. When we replace the pages, we replace the frontmost page. This algorithm is available to be used. However, the main problem that I saw when considering this one was Bellidy's anomaly. This is basically the proof that the more requests that we have, the more page frames, the more page faults we will also have. So I don't see it as being very reliable in our test case. Therefore, I gave that one a 6 out of 10. The third algorithm being considered is the MFU algorithm. This one works well. It works better than the FIFO in my opinion. It just is very expensive in terms of cost, especially when you're randomly accessing a frame. This algorithm is best suited, in my opinion, when you have a small sample size that you access frequently, or you have a large sample size that you don't access each of those frequently. This one's very similar to the LRU algorithm, but it's not as efficient in regards to performance, so therefore I gave it an 8 out of 10. The last and final algorithm I give a 10 out of 10, and I end up choosing, spoiler alert, is the LRU algorithm. That's the least recently used. It's very similar to the MFU. It's just, like I said, the complete opposite logic. This algorithm automatically processes it takes pages that are not processed or visited for a set amount of time and processes those. The LRU algorithm does not have Bellidy's anomaly. It avoids it successfully. It also does not have as consistent page faults as the MFU algorithm. It doesn't cost as much when randomly accessing frames. It uses a stack with the head and the tail. It also positions the recently processed pages on the top of the list, which makes it easier to access in that way. So this algorithm, in regards to our snippet of code, receives a 10 out of 10, and that's based on that we might not know what the input is going to be, especially when it's given. We don't know how big of the input we're going to get. So in regards to random access and overall efficiency and performance, I believe that the LRU algorithm will be the best. So like I said in this last slide here, I'm going to jump to number 7 now. The main reason I chose the LRU algorithm is because we don't know the values being assessed. We know the structure, but not the values themselves. Random access is the fastest in the LRU algorithm, and like I said, it avoids Bellidy's anomaly. On top of those reasons, the LRU also has a low number of page faults relative to the MFU algorithm, which was my second choice. So in comparison to that, I think it's a bit better. So in our case, the algorithm that will be simple to implement is we take the values given and place them on the stack, replacing them when needed, which is the least recently used way of doing things. All in all, I jumped to slide number 8, the summary here. Each algorithm does have different strengths. I'm sure you can make an argument for all of them, except probably the first one, just being that it is impossible to implement in this case. But the code snippet we were given benefits most from the LRU algorithm, in my opinion, due to random access, low page faults, as well as avoidance of Bellidy's anomaly and overall efficiency. Thank you so much for watching. I really appreciate you guys this semester, and have a good winter break.